Assalamualaikum warahmatullahi wabarakatuh. My name is Raja Muhammad Ashraf bin Raja Adnan. My matric number is B091810063. My supervisor name is TS Dr. Amir Abdullah bin Muhammad Damanhuri. Today I will present final year project presentation, which my title is Investigation of Temperature Variation on Thermal Ice Storage by using propylene glycol and water. My content in slide is problem statement, objective, scope of project, literature review, methodology, result and discussion, and lastly is conclusion. Introduction. Okay, thermal energy storage system like the temperature, place or power system can store heat or cool and utilize them later. The second, the energy is converted from natural source of energy to a temperature different in the water using during time of heavy energy demand, which is from 8 a.m. until 5 p.m. Okay. Third, thermal energy has three types. The first one, sensible heat storage. Second, latent heat storage. Third, thermochemical storage system. Okay, the problem statement is electricity costs a lot of energy and performance system, which is COP. Second, water has highest freezing temperature than propylene glycol. Third, use propylene glycol in ice thermal storage. Okay, objective project. The main of this research is to determine either propylene glycol mixture water with 100% water, which one has more efficiency with comparison of COP and also temperature. Okay, the first one, to compare the different temperature variation with 100% water and propylene glycol mixture water at thermal ice storage trainer unit. Second, to compare coefficient of performance COP for 100% water and propylene glycol mixture with water to the thermal ice storage. Okay, so scope of research, which is ice thermal storage system with capacity 45 liter water. Charging mode process for thermal storage with 150 liter ice store. Third, mixture propylene glycol and water in storage system with ratio 2/1 water glycol, which is propylene glycol is 33%. Okay, size of the system that using thermal energy storage based on needed cooling capacity. Okay, then refrigerant that used in thermal ice storage system is ARCS 134A. Literature review. Ice cool thermal energy storage has been designed and met us of many years now. Generally is called ice thermal storage system in order to efficiently comply with the need for cooling load and energy retribution in building. ITES depends on the operating mode, either full operator storage, storage type, and charge and discharge properties. Okay. For system operation mode, it has three types, which is charging mode, discharging mode, and also standby mode. So in this system, we'll use using propylene glycol, which is also used for heat transfer and grease protection. Similar to ethylene glycol, when inhibited, this glycol also protects HVAC system against damage from corrosion. Okay, for HVAC system, propylene is more suitable than ethylene glycol because propylene glycol has a lower toxicity than ethylene glycol. The third, minimum freezing point is -1.6 Celsius and maximum is -43 Celsius. Meanwhile, for minimum burst point is -2.7 Celsius and maximum is -53 Celsius. Methodology. So here my flowchart, which I start with literature review and then study about ice thermal storage, then monitor methodology, parameter selection, solidification of medium, which is propylene glycol mixture with water, and also pure water, which is 100% water. Then temperature, monitor analysis, result and discussion. So in this experiment involve 10 capacity sensor equipment which is used for measure the temperature of thermal storage. Time. So sensor data logger we place in a storage that contain glycol or 100% water for 16 hours. Then glycol ratio which is 2/1 water glycol. So before we start for a real experiment which is running for 16 hours, we do a testing running for the whole day to see the normal performance for ice thermal storage in order to make sure don't have any error during a real experiment. Before start running for 16 hours, this system will operation for 30 minutes first in order to monitor normal temperature for both medium. Here the data after 30 minutes. Okay. So for pH diagram chart, I will use a CoolPad software which can simulation tool of refrigeration and also the pH chart diagram. Here the sample of pH diagram after we fill in the data in a CoolPad software. Okay. So in this research, I will use COP, which coefficient of performance formula, which we must know H1 is for enthalpy of compressor, H2 is for enthalpy of condenser, and H4 is enthalpy of evaporator. Okay. In order to collect data, the system will running for 16 hours. First, we starting with 100% water for 16 hours, and another second 16 hours, I will use propylene glycol mixture water. Then, during that operation, we monitor the temperature by using data mini logger and display temperature. And after that, collect the data and create the graph and also pH chart for comparison temperature 100% water and propylene glycol mixture water. Okay. Here the result for 100% water after 16 hours. Okay. During this operation, ambient temperature is 22.6 Celsius and the outlet for compressor is 90.1 Celsius. Okay. Here result for propylene glycol mixture water after 16 hours and the ambient temperature is 20.0 Celsius and outlet for compressor is 79.1 Celsius. Okay. This table is show the comparison temperature for both. Which from the result we can see the compressor is highest than propylene glycol. Okay. Second, temperature water for propylene glycol is more cool with temperature 2.3 Celsius than 100% water which is 3.5 Celsius. Okay, this result effect due the lowest freezing point for propylene glycol than water. As we know, propylene glycol can go negative 47 Celsius and minimum negative 27. Here the graph comparison for temperature water. As we can see from evening starting time 5 p.m. okay, 100% water temperature is seen to be decreasing on this graph with temperature difference of 5 Celsius from the original temperature of 20 Celsius. Then the temperature of the propylene glycol began to drop rapidly at about 12 o'clock, which midnight, from 80.9 Celsius to 15 Celsius when the ice thermal storage system almost 8 hour operation. Then 100% water had a faster rate of temperature drop than propylene glycol which require 8 hour operation. So from the graph we can see starting from 5 p.m. until 12 we can see 100% water start drop rapidly only for hour operation, but for propylene glycol at midnight we can see the temperature will drop. Okay. So this graph comparison temperature for compressor also start from 5 p.m. until 10 a.m. So ice thermal storage using 100% water temperature compressor was 55 Celsius is more highest than propylene glycol which is 48.1 Celsius. The rate of temperature reached for glycol is very low when compared with 100% water. After 16-hour operation, the temperature for 100% water is the highest which achieved for 90 Celsius than propylene glycol, only 80 Celsius. So the difference between these two medium is 10 Celsius. We can see for 100% water, the temperature for compressor rapidly increase from evening to the midnight until the morning. But for propylene glycol, it's a little bit slow than 100% water. Okay, here comparison temperature for evaporator. Okay, for starting time from 5 p.m. until 11 p.m., which is 6-hour operation, the temperature evaporator for 100% water already achieved at 12.2 Celsius. Meanwhile, for propylene glycol temperature is 3.5 Celsius. Then it's rapidly dropped at midnight, which constantly drop until 16-hour operation, which temperature evaporator for 100% water is negative 31.9 Celsius, and for propylene glycol is negative 27.1. Okay, here the data that I get from experiment, so I put in a Skullpad software and input the data here. COP for both system, as we can see, COP 100% water and propylene glycol is a little bit different with each. For propylene glycol is 3.61 and coefficient of performance for 100% water is 3.38. So the comparison COP for both with is 100% water is 3.38 and propylene glycol 3.61 show the propylene glycol has the highest COP of the system. Based on this, COP propylene glycol is relevant to use because when more highest the COP, the system is become more better in performance. Conclusion: the coefficient of performance will affect the performance system, either the temperature, operation system, and also the energy. Second, the performance of system is based on the value of coefficient of performance, which is the higher the COP, the better performance in certain HVAC system. COP is very important for a big system such as chiller unit. Okay, third, from these features, we use two medium secondary refrigerant with each 100% water and also propylene glycol mixture with water. So propylene glycol is more efficient than 100% water in order for long term or lowest temperature. That's all for my presentation for final year's project. Thank you.